Good day, students. Welcome to our clip on how to graph transform trig functions. Before we go ahead and get started, let's go ahead and write down some information that's going to guide our problem solving process. So you just need to remember that if you have a function of the form f of t equals a sine b t plus c, or it could also be f of t equals a cosine bt plus c. This is how you find the relevant components. The phase shift you can find by computing negative c over b. The amplitude is basically going to be a units up and down from the center. Your period is going to be 2 pi over b, and that's going to be going side to side. And last but not the least is the frequency, which is basically the reciprocal of the period, which is b over 2 pi. Okay, so these are the pieces of information we're going to be using to set up our graph. All right. Okay, so let's write instructions for the examples we're going to be doing. So this is a task where to for the given trig functions, find the phase shift, amplitude, period, and frequency. Okay. After that, these are the relevant components. Then graph one period to the left, one period to the left, and another period and right of the phase shift. Okay. All right. So for question 1, we're going to be considering the function f of t equals 3 sine 2x plus 4 pi. Okay. All right. So what we need to know in this equation is what a, b, and c are. Okay. So to know what a, b, and c are, I'm going to write down the general form on the top of this equation. And it's basically going to help me figure out what a, b, and c are. Okay? Alright, so the standard equation is basically f of t equals a, in this case, is sine bx bx plus c. So just to make sure our variables match, let's use bt. Okay, bt plus c. Okay? Alright, let's make a slight change to this variable here. We have to be consistent with our independent variable. Let's make it f of x, okay? So x is our variable in this problem. Alright, so we can see that in this problem that a is equal to 3, b is equal to 2, and c is equal to 4 pi. Alright? You just map it downwards, you can see how they all match up. This is a, this is b, and this whole thing here is c. Remember, b is the coefficient of the variable. Okay, so the coefficient of x is b, which is 2. All right, now let's use that information to find the relevant components, which can help us to graph. All right, first thing we need to find is the phase shift. Okay, so the formula for phase shift is negative c over b. All right, so c is, we're going to have negative 4 pi over b. B is 2. If we reduce that, we're going to have negative 2 pi, because we just divided top and the bottom by 2, so we're left with negative 2. So this, since there's negative here, this means that we're going to be shifting to the left 2 pi units, okay? So this is a 2 pi units to the left shift. So let's put that here. Shift to the left, 2 pi units. All right, now next thing we need is the amplitude. Amplitude, what is amplitude? The amplitude is simply the value of A. All right, what's A in this problem is 3. So what does that mean? It means that we're going to be going 3 units up and down from the horizontal or the center. Okay, 3 units up and down to the max and to the min. Next thing is the period. To find the period, we simply compute 2 pi over b. Okay, b is 2, so 2 pi over b is going to be 2 pi divided by 2, the coefficient of x. If you divide top and bottom by 2, you notice that these two 2's divide out. 2 divides here 1, 2 divides here 1, and you're left with pi. Alright? So what does that tell me? Well, a full cycle is going to be pi, or a complete, a full cycle which has 4 quadrants. So in this case, this tells me that 4 ticks, which represent my 4 quadrants, 4 ticks is going to be equal to pi. Alright? And this is going to be going in the side-to-side direction. Alright, so we got to keep that in mind. Alright, now last but not the least, item we need to find is the frequency. The frequency is simply the reciprocal of the period, b over 2 pi. So instead of doing the work again, we can just reciprocate pi. The reciprocal of pi, since there's a 1 under there, is simply 1 over pi. Okay? So there goes the frequency. Alright, now let's go ahead and graph. So you notice that we're shifting 2 pi units to the left. So that means our new y coordinate, our new y-axis is going to be shifted to the left, okay? So our whole graph is going to be shifted to the left. So let's make our coordinate system. We're going to shift our original y-axis gets shifted to the right because our new y-axis is going to be shifted to the left. So you put it to the right like that. And let's draw our x-axis. All right, so this is your x-axis, and this is your y-axis. All right, so since our phase shift is shifting 2 pi units to the left, let's go ahead and first of all calibrate our axis, okay? So we're told here that the period is pi, so 4 ticks is going to be equal to pi, so we're going to go 1, 2, well, let me use 2 boxes, that will make it look nicer. So 1, 2, 3, 4, that's pi, and then another 1, 2, 3, 4, that's 2 pi. Okay, all right. So 1, 2, 3, 4, that's pi, negative pi actually, and then another 1, 2, 3, 4, and that's negative 2 pi. All right, so this is our phase shift requires us to shift 2 pi units to the left. So this will be our new y-axis. Okay, sketch it like this. This is our new y-axis. All right. Now, what does that mean? It basically means when we are graphing our points, this will be our point of our line or axis of orientation. Instead of looking at this to organize our points, this is what we're going to be looking at. All right, negative 2 pi. Okay, now max and min, 3 units up and down. So 1, 2, 3, that's our maximum from the center. 1, 2, 3, that's our minimum, negative 3. All right, so let's go ahead and draw in our max and min. I'm going to use a broken line for this. All right, so there goes our maximum, and there goes our minimum. All right, so now how do we graph the points? We're graphing a sine curve, right? So remember how your sine curve is. The sine curve is basically like the s's. So how do we graph our s? Where do we start from? Do we start graphing our points on this y or on this new phase shifted axis? Well, since we have a phase shift, this is going to be our new line of orientation. This line doesn't really count anymore. All right. So as we graph the points for the sine, we're going to start from the center. Go from the center, max, center, mean, back to the center. Okay. Since we shifted way to the left, we can just create another one on the right here. That'll be sufficient. So let's do it again. Center, max, center, min, and right back to the center. All right? Okay, let's go ahead and connect the dots, and that'll be our graph. All right? So straight out the center, straight, curve, and then curve, straight. Straight out the center, curve, curve, straight, straight, curve, curve, straight, and then straight, curve, curve, straight. Let's do the last piece again. So let me do that. Okay, so straight, curve, and then curve, straight. Anyway, this pattern basically continues forever. All right, so for today's classwork, I'd like you to just show me two periods. One to the left and one to the right. If you shift the weight to one direction, you can do two in the opposite direction as I did here. Okay? All right, so this basically is the graph of the function. All right, let's take a look at another example. For question 2, we're going to be graphing the function f of x equals -3 cosine 2 pi x minus 2 pi. Okay? All right, so we need to find our period, phase shift, amplitude, and frequency. So to do that, we need to know what A, B, and C are, okay? So let's write down the general formula on top. F of t is basically equal A. In this case, we're dealing with cosine B t minus C. Okay, the variable can be x or t. They're both independent variables. It doesn't really matter. All right, so in this case, we can clearly see that A is going to be A is -3, B is 2 pi, and C is going to be negative 2 pi. I made a mistake here. This is supposed to be plus C. Okay, so C is going to be negative 2 pi. So the question is, why is C negative 2 pi? Well, this is how it works. If the signs match, you don't change it. You just take it as it is. But if the signs do not match, you have to take the opposite in order for it to match. Okay? So let's go back to question number 1. You notice how this plus matched with that. So C is simply 4 pi. But for this one, there's a mismatch in signs. That is because C is negative in this case. So it's plus minus is actually plus minus 2 pi. So anytime the signs don't match here, you just take the opposite. Okay? All right, so there you have it. So now let's go ahead and find the pieces. Okay, so first thing we need is a phase shift. The phase shift is negative c over b. So in this problem is negative 2 pi over 2 pi. Okay. If you divide minus times minus is a plus, slash and dash, 2 pi times over 2 pi is just 1. Alright, so if it's 1, what does that mean? It means that we're going to shift, one unit, to the right, since it's positive. Shift 1 unit to the right. Alright, now what is our amplitude? What is our amplitude? Our amplitude is technically the absolute value of A. We don't have to look at its sign, so our amplitude in this case is going to be the absolute value of negative 3, which is 3 units up and down. We're just looking for the size, not the direction. Okay, so amplitude is 3 units up and down. Your period is 2 pi over b. Alright, so it's 2 pi over b. So b is 2 pi, so we're going to have 2 pi over 2 pi. 2 pi over 2 pi is 1. So what does this mean? It basically means that 4 ticks is going to be equal to 1 when going side to side. Okay? Alright, next is the frequency. Frequency is um, b over 2 pi or the reciprocal of the period. Okay, so since the period is 1, the reciprocal is going to be 1 also. Okay, now we have all the information we need to generate the graph. We're going to be shifting 1 unit to the right. That's a phase shift. So we'll shift our actual y-axis to the left a little bit, like this. And then let's draw our x-axis. All right, let's label the axis and calibrate. This is my y-axis. This is my x-axis. Um, 4 ticks equals 1. So let's go by 2's. 1, 2, 3, 4. 4 ticks is 1. And then we can go another one. 1, 2, 3, 4. 4 ticks, that's 2. Up and down, we're going by 3. So we have 1, 2, 3. That's our maximum. And then 1, 2, 3. That's our minimum. Okay, so let's go ahead and then draw our max and min. So there goes our max displacement from the central position, and there goes our min. Okay? Alright, now we have our phase shift of 1 unit, so that means that our new y-axis is going to be on the 1 like that. Okay, so this is going to be our new y-axis that we're going to use to orient our points for the cosine function. Okay? Alright, so there goes our new y because of the phase shift. So now how do we orient our points? We're graphing negative cosine, so we're going to be having the upside down cups. So where do we start graphing the upside down cup? Points for the upside down cup from? From the original y or from our new y? We're going to start from the new y because that's our phase shift, okay? So instead of starting from the max for the standard cosine, because it's negative, we're going to start from the min. Min, center, max, center, min. Okay? And going in the other direction, from the min to the center to the max, to the center, back to the min. Alright? And then we just connect our dots to create our cosine curve. So curve out the min, straight, straight, curve, curve, straight, straight, curve, curve, straight, straight, curve, curve, straight, and then straight curve. Okay? So the pattern basically continues forever. So this is a graph of the original function that we have. Okay? So there you have it. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to my channel by clicking up here. And please post a comment to let me know what you think about this presentation. More clips coming from matploserve.com. Thanks again, and have a wonderful day.